Okay, I'm going to show you how to find the distance from a point to a line. And for my example here, we're starting with this line right here that has this equation, y equals 3x minus 1. And I'm giving you this point right here, which I'll call P. And that coordinate is 4, negative 2 for that point. So when we find the distance from a point to a line, we want the perpendicular distance. So that means the shortest distance between this point and that line is from a line that hits it at a 90-degree angle. So, how do we do this? I wrote out a step list on the steps of doing this. And the first thing we want to do is find the gradient of the given line. The given line is this one right here. And if it's in gradient intercept form, the gradient is just the coefficient in front of the x. So I gave an example and I said if y equals negative 2x plus 1, then the gradient is simply negative 2. So for my example here, it's quite easy. The gradient is 3. What if it's written in a different form? It might not always be y equals something. It could be written like ax plus by equals c, which means something like 5x plus 7y equals 8. If that's the case, then the gradient is just the opposite of this coefficient over this coefficient. Okay, so as an example, if I were given this equation right here, 2x plus 3y equals negative 8, instead of rearranging this equation, the gradient is just the opposite of 2 over 3. Alright, so that's pretty important to know. And in this example here, it's pretty easy to figure out the gradient. After we do that, we find the gradient of the perpendicular line. And that's quite simple. So I want to find the gradient of this line right there. And the gradient of that line is just going to be what I call the opposite reciprocal of this value here, because the gradient of perpendicular lines have to multiply to get to negative 1. Okay, so just recap real quick. Gradient's 3, the reciprocal is 1/3, and the opposite means it's the opposite sign. So the gradient of this line is 3, and the gradient of this line is negative 1/3. So remember, I want to get the equation of this line. Once again, I'll go over I haven't gone over all the steps here, but here's what we've done so far. We found the gradient of the given line, found the gradient of the perpendicular line. We're going to write down the equation of the perpendicular line because all we need for the equation is the gradient and 1 point. And then what I'll do is I'll find that point of intersection, which I'll call Q, of these two lines by solving simultaneous equations. Once I have that, I have the 2 points that I could use for the distance formula. And I'm going to use points P and Q. So I'm going to label that point of intersection Q right now. There we go. So that the Q isn't that point right there. It's the point where the two lines meet. Alright, so let's keep going. Okay, next is find the equation of the line and the equation of the perpendicular line. I use my formula right here for equation of a line, and I substitute in my perpendicular gradient, and I substituted in my point P right here. And then what I do is I'm going to rearrange this equation so it's in the same form as this one. So I want to get y by itself. And in order to get y by itself, I distribute that negative 1/3 through, expand that negative 1/3 through, and I get y plus 2 equals negative 1/3 x, and remember, negative times a negative is a positive. And then finally, I take that positive 2 and subtract it from the other side. And so, my equation for this line right here is y equals negative 1/3 x minus 2/3. It's got a gradient of negative 1/3. Okay, so now I have two equations that I'm going to solve by solving simultaneous equations. Okay, so that's my next step. The whole point is we have this point, we find its gradient, we write an equation, and we solve this pair of simultaneous equations. And when we solve that pair of equations, what we get are the coordinates of point Q. We get the coordinates, and then from the coordinates we can use the distance formula. Okay? So let's solve that pair of equations, which there are several ways of doing it. Alright. One way to solve the point of intersection is by using a graphics calculator. And I have the answer right here. And to use a graphics calculator, if both of them are written in gradient intercept form, which they are, then I just use the graphics and find their point of intersection. Okay, which in this case it's going to be 0.1 and negative 0.7. So that's that point right there. I've got it. It's quite easy. I just graph it, find the point of intersection. Okay, but I'll show you how to use algebra to figure it out as well. So since these two equations are both equal to y, to solve for x, we're going to set these two expressions equal to each other and solve for x. And there's some fractions going on here, but it's not too bad. The first thing I want to do for solving for x, and if you know how to do simultaneous equations, once you get the value for x, you can substitute it in here and get the value of y. So the first thing I'm going to do is take these two terms here, negative 1/3 x and negative 1, and swap them around, changing their signs. Like that. So now I have 3x plus 1/3 x equals 1 minus 2/3. I collect like terms on both sides, and we can use a calculator for this. I get 10/3 x equals 1/3. So to solve for x here, we take the constant term and divide it by the coefficient. And of course I get x equals 0.1, which is what I would have had up here from the graphics calculator. Now to find out the value of y, I take that and I substitute it into this equation here. I could put it into this equation, but this one has no fractions and it just looks easier. And of course I get negative 0.7 as the same I would have had up here from using the calculator. Okay, so now that I have 2 points on my line segment, I am ready to use the distance formula to calculate that distance right there of PQ, since I'm given x1, y1 and x2, y2. Okay, here are my 2 points, and x2, y2, x1, y1. It doesn't really matter which one you make, x2, y2. I mean, you could have these swapped around and your distance will still work. Here's my distance formula. Now it's time for some substitution. And I get a distance of 4.1. I don't have units on this. I don't have centimeters or meters, so I'm just going to leave it with no units and just say it's 4.1. You could write down units if you want to. But that's how we do it. And one thing we need to be careful of is entering this on the calculator. We've got a lot of brackets going on, and if we are doing this, we can either work this out separately and then work out the square root. But if you do it all in one go, you're going to have to put all of this in brackets as well before you do that square root symbol. So you'd work kind of double bracket all of that to show the calculator you want to put all of it under the square root symbol. And that's how we do it. So I'll go through the steps. I'll go through the steps one more time just to reinforce it. Okay, so once again we find the gradient of the given line, and we can do that these two number of ways. Then we find the gradient of the perpendicular line, remembering that the gradients multiply to get to negative 1, and that's what I refer to as the opposite reciprocal. We write the equation of the line using the general formula here. We find the point of intersection of the two lines by either graphing it or solving simultaneous equations. And finally, once we have the 2 points, we use the distance formula to work out the distance between those 2 points. And that's how we do it. Good luck.